All right, guys.
Like I did, but I really do that. So I could have.
I want to see if we can get
I looked at it a little bit yesterday, but it's like it's not like I was like,
3 complicated problems, examples, and once we get through those, everything else will hopefully seem easy, right? So again, the strategies to doing these proofs, look to the complicated side usually, and maybe convert things to sine and cosine, use the Pythagorean identities. Then there's the algebra stuff, which again, you guys, most of you had algebra 1 online. Look for the least common denominator. Look to undo factoring, so multiply things out, boiling, whatever. Look for difference of squares, things like that. So we did, well, just real quick, this is 18 from last night's homework. An identity. We will give you these, the ones that have all the squares in them, but you need to know how to use them. So that says secant squared minus 1. All right, subtract 1 from both sides of the identity that we give you. So secant squared minus 1 is tangent squared. So that's how we did this step. Secant squared minus 1 got taken away, and its equal amount was put in. Are you guys okay with this thing? Can I rewrite that fraction this way? 2x over 3, can I write it as 2/3 times x? Yes? Yeah, I can. Just want to make sure, because right here, they wrote tangent squared as sine squared over cosine squared, and then pulled sine out in the bottom and left it on the bottom. We okay with that bit? Yeah, Francis?
If you're dividing, like, because the tangent squared is divided by sine, wouldn't you flip it?
Okay.
Because isn't it technically dividing by the...
Good point. So let's, I prefer this explanation. So tangent squared divided by sine, I agree. Tangent, I'm going to write as sine squared over cosine squared because that's a thing. Dividing is multiplying by that guy turned upside down.
Oh, so it would be turned upside down. Okay, thank you.
Cool? Okay, that was 2 ways to show the same thing. One of the signs up here cancels with the sign down there. Rewriting what's left over, sine over cosine squared. And then again, we will give you these. Sine squared plus cosine squared equals 1. So Maya, what do I need to do to this to get just what cosine squared equals? I want to get cosine squared by itself, so I got to get rid of subtract sine squared theta. So cosine squared equals 1 minus sine squared, and we ended up with the right-hand side. Long, complicated. Martha, they like puzzles. Really, they're fine. You will enjoy them. Or you will suffer through them like every other pre-cal student. Okay, we did this one also already. Do we need to do it again? It's painful. We don't want to. 2 people shook their heads, so we're going with that. Okay. So you guys write your problem down. There's no squares on there yet, but I'm feeling like we might need that identity. Carolina, do you remember the identity that has like tangent squared in it?
Is it 1 plus tangent squared equals secant squared?
Perfect. the homework from yesterday, we had done a couple of problems as practice in class. So the first thing was, so Erin, I was like, pick the more complicated side. Both sides seems to kind of be poopy. So what side would you want to start with?
And I guess the left.
The left?
Sure. About the same.
They are about the same. So if we started on the left, does anyone have an idea before I give you a hint? Elon? I cannot cross over this equal sign. And don't work on both sides. Because hang on, the equal sign is in question. You have a different idea?
You square.
If it were square, it'd be tangent squared.
I can't square, I can only multiply by 1. Erin, what would you say?
Just turn tangent and this sine over cosine. Start.
Oh, wow. That would be painful. It would work. Tori?
Denominator?
Common denominator? Kind of. Like how, well,
Like, you do like secant x minus 1 times like tan x, and you do the whole fraction thing.
okay. So, and Anoop, what were you gonna say?
I was gonna say that, yeah.
Okay. What were the other ideas?
Like, well, you just have to see the minus 1 the x.
Okay. So, all right. Different ideas, and they're all pretty good. So Tori's she said, at least what I think I heard, this side has a tangent on it in the bottom. So I need a tangent on this side. And I think what Maya was saying is this side has a secant plus 1 up top. So this guy needs a secant plus 1 up top. So I'm going to try this 2 different ways. I'm going to do Tori's method first. Since I can't do what Elon wanted to do and cross multiply, I need to just work on one side. This side had a tangent in the bottom, so how do I get one there? I force it. I'm going to multiply by tangent over tangent. When I do that, up top, I get tangent squared. Do not multiply these out, just leave it factored. Phote, from this identity, what does tangent squared equal?
Secant squared. Or is it 1? Secant minus. Or secant minus 1.
Secant squared minus 1. Okay? Good. Okay. That's a good idea. Okay. And then we need to remember algebra. We did some patterns yesterday, which I thought they were on this flip chart, and I might have opened the wrong one, but when I do a plus b times a plus b, that's a squared plus ab plus ab plus b squared. So it's a squared plus 2ab plus b squared. If I do a minus b times a plus b, this is the conjugate. So algebra, if you have this, it becomes this. If you have a minus b, so factoring. How does that numerator factor? Does it have anything does it look like one of these patterns? Colin, what do you think? Does the numerator here, secant squared minus 1, look like either of these patterns? Is there a perfect square minus a perfect square? Yeah, so how is this guy going to factor? Secant x minus 1 and secant x plus 1. Yep. Andre, there's an electric one on the little rolly thing. That thing eats pencils. Crystal, what can I do with what Colin got for us?
That's why I was secant x minus 1.
And what am I left with, Israel?
Secant x plus 1 over tan x.
Secant x plus 1 over tan x, which is that. Okay. So knowing these patterns, difference of squares, what it looks like factored, and what it becomes once it's multiplied out. And this one, when it's factored, and what it becomes when it's multiplied out, is kind of important to get more comfortable with those. Questions on this? That's the next one. The next one is just such. Oh, you're excited. I can just see the joy.
Every time I heard a math teacher say we're about to have a really good time, it did not work out well.
I know, that was sarcasm, maybe you can smell it. Okay, you ready?
I don't even need a nose for that.
So from what we just reviewed, algebra, what is that going to expand to? X plus y times x plus y, which is what? It going to be fully expand?
X squared plus x, 2xy plus y squared.
All right, some of you are on it. Okay, find that. Write it out like sine x plus cosine x times sine x plus cosine x. Yeah, tell me, here's the fun. Yeah. Shouldn't be allowed to have this much fun on a 2-hour device. Tuesday.
So why don't we just don't?
Right.
Let's not say we
Just
did.
have some boring barren time.
Yeah. I hear you, buddy. Go for some more bear time.
Did I get it right?
Probably.
Okay, so again,
What's the difference between opinion to the
A lot. What's the difference between 2 times 5 versus 5 to the 2? A lot. 10 versus 25.
Well, I don't think it's like,
All right. But multiplying this out, sine x plus cosine x times sine x plus cosine x, sine squared plus 2 sine cosine plus cosine squared. But then, Clark, what's the cool thing about that?
Sine squared plus cosine squared equals 1.
Sine squared plus cosine squared equals 1, so it becomes this little tiny thing.
It's pretty dope.
Yeah, right? We're getting the party started here. You ready?
Yes, sir.
You just gave a look of like, please God, let the bell ring. All right.
No, I know I've been here for a while. 14 more minutes.
All right. Yes, what a great day to choose to record this class in all its enthusiasm. Okay, write the problem down. So third period wanted to cheat and said, oh, well, I see this down here, so I'm just gonna plug that thing up there. You wouldn't honestly know that right away. So, I don't know, you would start on which side?
I was on the right. No.
I mean, they both stink. And let me tell you, we started on the right side in third period and it was just a big old mess. So let's try the other side, but I don't know what to do because I don't see the numerator on either one. Any suggestions? Given we talked about what a plus b squared looks like and what a minus b and a plus b, like, we're gonna be using these conjugate things and we're gonna be using that on a lot of stuff. Yeah,
So could you do like the sin x minus cosine x times, oh, yeah,
so,
so the common denominator?
okay, so I wouldn't exactly say common denominator, but how about, I don't know. Let's try that. So guys, it's a mess, but multiply the numerator together, clean things up, multiply the denominator together, clean things up. Nice answer. I mean, the point of some of the things I just showed you, in the numerator, do we have a plus b times a minus b? Yeah, so Francis, what does that become? Quickly, the conjugates multiplied together. A minus b times a plus b. What is that?
A squared, minus,
Minus b squared. We're not gonna do it the long way, because there's too many letters, too much stuff to write. So, this top times that top, is it, Elon, is it the pattern a plus b times a minus b? Even though it's not really a and b, it's cosines and
Sine
sines.
squared minus cosine squared.
So Clark is saying that it becomes sine squared minus cosine squared. Right? Tell me, isn't this fun? Yeah. And what did we get a second ago up here when we multiplied sine plus cosine, the whole thing squared? Jason, what did we get?
1 plus 2 sine x cosine.
1 plus 2 sine x cosine x. Look at our goal. Do we have the denominators matching? Yeah. All right. The numerator isn't quite there yet. Ferris, this side is 2 sine squared, and this side's got a cosine squared. So how do I get rid of cosine?
You add it?
Well, I can't cross over this equal sign.
No, but like for Pythagorean identities.
Okay, in the Pythagorean identity, so cosine squared equals what?
Cosine squared equals 1 minus sine squared.
Great. Sine squared minus parentheses 1 minus cosine squared. You know what happens in the numerator? They have like one more step to do. Minus and negative cosine squared becomes, sorry. I plugged the wrong thing in. I apologize. Ferris said cosine squared equals this, and I wrote the wrong thing in there. So sorry.
I'm kind of confused, like, when
All right. So I didn't do what Ferris said. I wrote the wrong thing down. He said cosine squared from this. He said cosine squared equals 1 minus sine squared. So he subtracted sine from both sides. So this was supposed to be 1 minus sine squared, which is what he said, and it's not what I wrote. Apologies. And then distributing the negative, so Tony, bring it on in. What is sine squared plus sine squared?
2 sine squared.
And then the minus 1 stays there. Did we get the other side?
2 and then
Did we get the other side?
yes.
Woohoo! Wasn't that just like so fun? Longest day ever, 2 hours short. Yeah, Aaron, and it's still not ringing. The bell is still not ringing yet.
How does the negative in the sine squared, 1 minus sine squared, go to positive?
Because of what Margot just said.
Okay, we're,
Okay, because cosine squared is this whole group. So that whole group, I'm gonna put parentheses around it. And then I need to distribute that negative to everybody. I got 2 kids. If you ever gave one kid the candy but not the other kid,
The other kid will probably just throw the rock.
there would be some tantrums. There would be some fights.
Violence.
We weren't really a violent type, but there were some tantrums till equitable distribution of chocolate had occurred.
And communism.
Okay. All right. So hold on before you guys do funny things.
that's what my handwriting says too. I don't think we can do that, but.
Not quite. Bummer. All right. Those are the 5 problems that are your homework. Can you guys take a picture? Not yet, but they will be shortly.